My topic is about generalizing informed sampling for asymptotically optimal sampling-based planning via Markov chain Monte Carlo method. Considering velocity constraint in planning will change the geometry of a plane trajectory. For example, we model a robot's left arm joints using double integrator as in the left figure. In order to reach a goal position with a high velocity, the arm needs to backward a bit so there will be enough acceleration space in moving to the goal position. In the right figure, you can see the dynamics between with and without velocity constraint. We need an optimal kinodynamic planner that can efficiently generate a trajectory subject to the kinodynamic constraints. For example, the velocity bounds and acceleration bounds, and also the environment constraint, for example, the obstacles. We would like to generalize informed sampling to kinodynamic planning problem, in which the problem space is combined by both the configuration state and also the velocity of the configuration. In an anytime planning framework, there exists an informed set that will gradually shrink as the current best solution improves. The informed set is defined by the current best, which includes all the states that will improve the current best without considering collision. In geometry planning, there exists the hyperellipsoid that defines the informed set, which could be analytically calculated. In kinodynamic planning, the shape of an informed set can be arbitrary. It depends not only on the current best but also the start and goal position. Also, it could be discontinuous due to the feasibility determined by the constraint, the objective, and the system dynamics. Using rejection sampling can be very inefficient because the volume of the informed set can be very small compared to the entire sampling space. Later, hierarchical rejection sampling is proposed to reject sampler before fully evaluated, but it can still not be ideal in high-dimension state space. In this paper, we introduced Markov chain Monte Carlo to generating samplers. We define a target distribution as an informed distribution over the informed set. Experiment, we found that hidden round sampler, which is one approach of Markov chain Monte Carlo method, is significantly better than all other approaches, especially in high-dimension space.